slides are going to be a bit dark or washed out rather. But yeah, so hi, I'm Justin, and I get to talk. Oh, a little closer. So hi, I'm Justin. I get to talk to you today about the Haxe Lua compiler. It's a Haxe is a cross-compiling language. It has many targets, and recently I added Lua to the base of languages that it supports. So here's the official list, and I think as a language, I don't know how many people here have heard of Haxe. Oh, that's awesome! Yeah, it's a lot more than last time I was giving this talk. It's kind of slowly emerged as a language that you can do a number of different things with. I know we just heard a talk talking about how languages are specific and there's different goals for different languages, and that's all true. But at the same time, there's a subset of language functionality that is useful, and Haxe takes advantage of that and basically lets you write very robust and sophisticated applications with certain assumptions. So you need a GC, you need basic array and hash functionality. So basically, it's been able to emerge out of the ActionScript Flash domain, and now it's expanded to JavaScript, and then to C++, then to Java, then to Python, C#, and now we're at Lua, and this is sort of the first step out of the gate for this target. So a little bit about myself. I'm based in Seattle. But I work down in Salesforce, so unfortunately you guys had to deal with Dreamforce all last week. So I'm sure a lot of you are glad to have some return to normalcy there. But my background there was basically this intersection of machine learning and really rich internet applications that typically had a lot of sophisticated front-end and back-end operations. And I've been part of Salesforce's data science team now for some time. And so I can't really say that Salesforce is here, and it has a lot of Lua projects in the pipeline right now. It's just me, but this is something that I'll talk more about later. But I think there's a lot of potential there, and I'm trying to. My team in particular does a lot of work with full stack demos, for instance, like doing different demonstrations of machine learning concepts and exposing them somehow in some novel way. So we're regularly tasked with juggling a lot of really complicated languages and targets, and expected to produce something that we can show. So Lua has a lot of interesting things that it can do, and but then it needs to kind of join forces with other languages and frameworks. And so I've been a real big fan of Haxe for doing this. It's served me well in other situations where I've had to do things like this. So in general, though, why Haxe? I think this is the main question. Why is Haxe being talked about at a Lua conference? And I think the main thing in my mind why I've stuck with this is that its focus is on empowering the developer. It doesn't have a major company backing it. It doesn't have any kind of goal outside of just helping people produce things and tackle projects that they wouldn't otherwise be able to do with a single language. So on the right, you've got a series of games. I don't know if anyone's heard of Papers, Please. It's a BAFTA Award winner in 2013. There's a few others. You might have seen these on Steam, Greenlight. I'm not a huge gamer, so but these are all cases where people have been able to basically use Haxe to overcome all the different platforms that they would have to tackle, and basically start from scratch. They don't want to plunk down thousands of dollars for a toolkit or for an engine or something, but basically just to get their idea, their dream out the door. And Haxe has a really solid track record of delivering that. And then on the left, you've got a lot of popular frameworks. And I mentioned these just because they're other examples of people being able to support themselves. A lot of these guys now are working full time on this. And they're really doing a lot of amazing things in terms of letting developers access the full potential of all their devices and platforms. And so Haxe as a whole, I think is really compelling for games, especially for individual game developers. But I think it's also magic for web, mainly because it can target both the back end and the front end simultaneously. It also is strong for mobile. You can handle Android and iPhone apps with native code, since that's what Haxe generates. And then, of course, desktop, command line, and cross-platform APIs. The other great thing about Haxe that I think isn't mentioned enough is that it is a statically typed language, and I think that turns off a lot of people that are used to dynamic languages. And I think a lot of that aversion might come from languages like Java, which are cumbersome, which take a lot of time for the compiler to resolve, and then it takes time for the JIT to heat up. And I just wanted to show an example of these are two runs of our base unit test suite. At the top you have Java, and you can see that, like, from soup to nuts, from compiling the Haxe code to running it and executing, it's 27 seconds. Lua, on the other hand, is only 3. And the way that breaks down in terms of time is it's a tiny fraction of a second that Haxe actually needs to compile all the code. And then it hands it off to Java, and in the case of the Java target, and then Java takes just an eternity to execute all the things it needs to do to produce the jar. Then the jar speeds up, the jar spins up, and has to run execute the code. With Lua, it's basically it's all just the runtime that you're seeing there. And with the 6,000 tests or so here, that's touching almost every feature of the compiler. So basically turning everything on, all the macros, all the you name it, and it's hitting every feature of the compiler, and it's still finishing the whole thing in under 3 seconds. So the time to sort of experiment or the interactivity you get with your code is not diminished. The compiler is actually helping you. And on the right here, you've got a little tiny call-out window showing a small editor view, and it's actually showing a completion request. And I think this is, not many compilers do this. I actually don't know if any other compiler does this. The compiler actually provides you the completions. It's not doing some kind of static analysis of the code on the page. The compiler is actually fast enough that it can respond to a key press. So what does Haxe look like? So I think this is sort of this is the example you'll see on the web page. And I think this should be, if you use kind of standard ECMAScript-based languages, this should be pretty familiar. And I think one thing to point out here is, there is some extra ceremony involved in setting up a Haxe file. You have to declare a class. If you want something to just kind of run automatically, you have to declare a static name. And then there's some other nice features in here. This isn't going to be too shocking, but you've got a basic string map here, you've got a for iterator, you've got some string interpolation here, but you can kind of see what this program does without even knowing much about the language. It's basically, we've set up a map, and then we're going to go iterate through those keys and type out what these people do for a living. And then down here you can see how the compiler is working to interpret the structure of this file, and then how to generate. So like this is basically what I've added. You can change that tag to Java, you can change that tag to Python, and you're going to get the same output. And so that's nice. There's actually a lot of nice things here. It's very consistent. And there's a lot of things that you get for free, like nice string interpolation, that then you can use cross-platform in a lot of different ways. And the other key thing here is you'll notice that I mentioned Haxe is statically typed, but there's no type information here. Like you don't have to go the Java route of declaring the type for an instance and the type for the constructor. It's all you can write. This is all still typed, but Haxe uses type inference. So if you're explicit with how you're declaring what's in your variables, Haxe will automatically assume, like, oh, this is a map containing strings, etc. So it's wonderful getting out of your way, I guess is the way to say it. And it actively helps you through completions and through its helpful error messages understand, what you're missing in your variable declaration and how to address that. It actually does spelling suggestions. So I don't want to go through all of these, but I just wanted to say that I would say unless you're using something like Scala or Haskell, Haxe will probably be the most sophisticated language that you use. And I think that the key selling point is that all these compile time features are available for all these different platforms. So you have a whole slew of static analysis features. You have metadata, reflection. You do have classes, interfaces, and inheritance. You've got different types of you've got special typing properties that I can't go into now called abstract types and AST macros. And so there's a whole slew of goodies here, and it's a good way of getting exposure to these features and sort of understanding how they can be used to help construct Lua programs. So the next question is, how I got involved with Haxe and explain why Haxe is useful, but why Haxe and Lua? How did I get here? The first question is why not? But I think that's all I should have to say. I'm just sort of I like hacking around on things. But really, I think one of the things that I was seeing was. I'm someone where if I have a little nit in the back of my head and I see a language and I don't know it and it's at the bottom of a lot of really interesting things, I'm kind of compelled to learn it and figure out what makes it tick, what makes it so good. And I kept bumping into Lua and LuaJit, and it showed up in Torch. It shows up as a scripting layer in Nginx. It started. It was the first class scripting choice for NeoVim. So it kept popping up, and I was like, "What is this thing?" It's like, it's so small, but it's sort of this abstraction that I don't understand. But it's seemingly so simple. So there, I mentioned scripting editors, and then it shows up in games as well. This was a whole other. I saw all the ways people could abuse, some of these game engines with scripting, and it was pretty amazing. And then when you look at the Lua community, the other thing that seemed to be a match was that there's a lot of similarities between the Haxe community and the Lua community. There's a big emphasis on individual game development, and then web development. So there is, I think in many ways, the communities are very related, and if I get to be the one to introduce them, that's great. And then, so why Haxe and Lua? It's a little bit of this comes out of boredom, mainly because I recently had a son, and it turned from when the parents come in, I became sort of an accessory, and I could basically go off for hours at a time and think about stuff, and I wasn't working. So a lot of this just came out of finally having some time to think about something else and tackle a new project and learn something new. So then when I say, so now that I've mentioned, why Haxe and Lua, which Lua are we talking about? I mean, I think it's already been referenced here. There's version changes that have happened. When we talk about LuaJit, we're not talking about Lua. And this was confusing to someone like me coming in. When you see all these projects that are, with LuaJit as a background, and then Lua 5.3, but then you can't use those language features. That was sort of a hang-up for me. So that didn't sit well, and so what I wanted to do was basically go through and target as many as I could. So I have to put an asterisk here because there is one of the things that's happening with Lua 5.3, and I can work around it, but there's new operators getting introduced. So if those exist anywhere in the script, I can't I can't have a single source that I can just deliver and say, here's something that'll work across all these platforms. Because if those bitwise operators are in there, things will break. But with the minimal like backwards compatibility patch, that's good. And so, you know, whenever I say these things, I'm sure some of it's going to be contentious. Feel free to tell me I'm wrong. This is my first time being in the Lua community, so I'm hoping to get feedback like that. But this is just, you can look at this as an outsider coming in and saying, like, how can I use a static compiler to get rid of all these inconsistencies and give someone like a turnkey solution for just running this Lua script wherever they want. Oh, and by the way, you'll see things flagged in green. This is actually the second time I've given this talk. The first time was at the Haxe conference in Paris this summer. And the things in green reflect new features and new announcements. And so abstracting away all these inconsistencies was kind of a pain, but I managed to do it. And so this is an announcement, so to speak, for support now on all these versions. And I should also mention that I wasn't alone in the Haxe community in my interest in Lua. There's been other people. Whoa! Okay. Sorry. Good recovery.
Go ahead.
So there's been various members of the Haxe community that have been interested in Lua at different points in time, including one of the original language authors. Found inspiration in it, and but this was, I think they all kind of petered out at some point. It is a tricky target to handle. So I think as far as I can tell, this is the first time it's kind of crossed the finish line in the sense of successfully completing all the unit tests, successfully being an integrated part of the Haxe ecosystem. And I just wanted to give a quick example, like what's A versus B. If you got Haxe coming in, what does a Lua look like coming out? And I put a lot of effort to try to make it look as close to what how an individual might write the Lua, but with the caveat that it's still going to be computer generated. This isn't going to be something that's going to look handwritten. And so you have here on top, you've got the Haxe source code, and at the bottom you have the generated Lua. And so you notice that it basically builds up this table reference for this type definition of main. It declares the main function and calls it. And there's some special helpers and things. And in the previous talk I gave this summer, I went into them, but I'm not going to have time today. But they basically, this Haxe O helper and some other anonymous helpers basically handle the issue with null fields, where you can't tell, if something's null, it might as well not exist, or nil, sorry. So there's some special handlers that detect, when you do have a type definition for an object, it'll retain that information of what fields are present, and then using reflection later you can determine whether or not that field is actually present. So it basically lets a Lua table behave like a Haxe object would in other targets. And then we mentioned BitOps. Of course, this is something I'm still trying to accommodate in Lua 5.3, but there is a translation layer that happens where the bit operators turn into the bit methods, and then I in turn wrap the bit library in another library that patches over inconsistencies I found with LuaJit bit operators. And then there's unary operators like the standard X++. Those get translated into a series of statements and expressions. And then there's some special things that Lua will do, and every target is like this, where Haxe just can't support it across all platforms. And so the conventional way that Haxe supports this is with these notions called metadata. And there's these little @ signs and a tag, and whenever you add them to a class, and you're compiling it for a specific target that respects them, it basically unlocks the ability on that target. So you can imagine there's a native command, for instance, that binds to a non-conformingly named interface. So if you had if you wanted to target some other library like a Lua socket or something like that, and it had some kind of naming convention that doesn't work within Haxe. Haxe requires all class names to be uppercase, etc., and it needs module names. This lets you basically it lets you write it as if it were a standard Haxe class, but then target that underlying Lua implementation consistently. Expose lets you, if you wrote some Haxe Lua code you wanted to use outside of your Haxe project and other Lua projects, you can basically expose it and keep other things private. There's a self-call flag that lets you, it basically lets you expose kind of dynamic properties of the table and its methods, lets you function as a table or as a method. And then include file, if you have helpers or things that are just too messy to express in Haxe, you can basically add them in and then you can use them as a helper library. And then this is cool. I'm sorry, this is pretty dry, but this is kind of one of the trickiest problems with Lua is that it returns multiple values. If you work with other languages, this was kind of it was a foreign concept to me at least, because it makes total sense. You just return things back on the stack, and that's great. But if Haxe doesn't support that, the typedef signature for a method, it says you have to give one return value back. So that was a big blocker. So we came up with this clever technique, and I can't even I can brag about this a little bit because I didn't even crack this one. This one was actually another Haxe compiler developer named Nadako. But basically, we set up a proxy type, and you can see this at the bottom here. At least I hope you can. We tag this with multi-return, and then we define basically a fake class. This is called string find. If you use the basic string find method, you know that it returns two values, the beginning and the end of the match. And so what you can do is, so you can see here a bunch of different features. Here I'm calling this data string tools just for clarity's sake. I'm saying it's actually targeting gstring, the global string method, and then I'm saying here's all the arguments in define, and I'm saying it's returning the string find, and then I'm saying here's what string find looks like. It has a beginning and an end, but this order is important. This order is the order of the arguments in the stack. And what will happen here is, I don't really have a hand free here for this, unfortunately. But the Haxe compiler will be clever enough to tell if you're referencing that return as an instance. If you're passing that around, that entire, if you're passing around the begin and the end, it'll wrap that in a table with the named arguments, so that you can use it like a normal object. But that involves some overhead, right? You have to wrap it in an object. You don't want to do that every time. If you just reference one of those fields, what the Haxe compiler will do instead is basically either it will expand that return into the two arguments that the multi-return define, and then just use that one reference. So I guess in summary, you can see over here this is the boxing method. So this is where we're basically printing out the whole thing. We're boxing this. We pack the results in a table, and we've labeled them. Here is where this is actually using a select statement because we want that second return value, and then here's where we want the first return value. So we can just call the method that will return that by default. So this is all like a consistent interface, but under the hood, the compiler's choosing the most efficient implementation, which is really nice because I mean a lot of the efficiency of Lua and LuaJit is ability to not wrap results. It puts them back on the stack, and so avoiding any kind of overhead where possible, lets externs basically operate, I call it without impedance. There's no overhead for using these abstractions. So this was also just something we just figured out recently, and this is in the latest build. So this all sounds great, and I'm painting a pretty cheery picture, but this is also, I just want to also be clear, this is alpha. We're having a good time with this. I think like we're knocking these problems out as they come, but there's still some problems lurking that are going to take some workarounds. And yeah, we're just kind of casually going about our business. But we still have we still have some like problems that Lua has that other targets don't have, and so they're surprising. One is that you have this 200 local variable limit in a scope, and Haxe basically does all kinds of things under the hood that might create temporary variables for different reasons, like unary operators, etc. So, finding some kind of mechanism to mitigate that is in the works. The sys API is incomplete. Mainly, Lua is very minimal. It's very unopinionated about, how to open file, not necessarily files, but how to deal with processes. It lets libraries stand in for that. So I'm working off of libdb and love, but if there's other opinions and ideas on that, I'd be happy to hear them as well. And then there's some miscellaneous things, nils and nulls and string concatenations, throw errors. Some other targets have this same problem too. I'm trying to come up with an efficient way of working around that. And then there's also, just some basic techniques for how do you avoid pain and humiliation with dealing with the Lua target. There are some, there are going to be some fundamental differences between Lua and some other targets, and a lot of it circles around this 200 local variable limit. Even with the workarounds in place, like if you exceed that number, it's going to be a non-local access. It's going to be slower. So in general, avoiding a technique called inlining that results in temporary variable creation is a good idea. And then the rest of these, I don't want to dwell on these too much. The Lua args, the dots, I think, is actually not a good idea for the JIT. So maybe I read that wrong, but that was in one of Mike's optimization guides. So then the next question is, this is all new. Like, what is anyone else doing this, or am I the only one? So the interesting thing here is there's different game frameworks out there. One's called Love. I haven't used this, but I was kind of shocked to see in less than 24 hours after I announced the Haxe Lua target, there's already a wrapper for Love in Haxe. And it has warnings on it saying, this is like half-baked, and but it was a great show of someone was eager to try this out and try to use Haxe for their Lua projects. I've got some projects that I'm working on personally. Okay, so I'm going to go through these real quick. Nginx, working on that. Warcraft, working on that. There's a list here of links, how to get started, manual, etc. I'll post those to the group after this. I'm going to get to the conclusion. And I just want to underline that the Haxe and Lua communities are very similar. And I've been really impressed with the things that people have accomplished with Lua. And even though the languages are different, I think it's at the core it's the same people. And Haxe as a language is very standard and unsurprising. I think you learn it very quickly. It's ECMAScript-based, multi-paradigm, object-oriented, functional. And I think also important here is that Haxe provides a way to leverage an existing language ecosystem while moving towards something else, like growing in another way, developing expertise. So the clear point there is that you don't leave the Lua community by joining the Haxe community. It avoids impedance mismatch, the extern support that I mentioned earlier. And it provides a lot of convenience and power in its typing methods on top of dynamic languages. And it honestly has a great track record of doing this across JavaScript PHP, etc. And in closing, I'd say, if anything else, it's a great way to learn programming, like how all these languages, accomplish what they do, and how Haxe gears itself to take advantage of that. I think has really been insightful for me, and that brings me to the end. And I'm happy to answer any questions. Sure.
How do you deal with the multi-percent thing? How do you deal with things that return a different number or different styles of percents? You can like pass a variable through or any number of percent values.
That's a real good point. And so so first of all, you can outwit me. Like you can write a function that returns something that I can't type in a normal way. But if there's a certain sequence of arguments that leads to a certain structure of an output, you can provide different signatures as an overload and define different multi-returns. That adds a little bit to the overhead of declaring the function, but I think that's good practice. Like you don't want to have the function return random types and output. Like if there's some kind of structured way to return, then Haxe has a way of declaring that as an extern and then giving you the right type.
I'm more curious around how you declare externs like coroutine.resume, where
yeah, that's super tricky. And I think that the coroutine resume
or people or anything that's not returns.
Yeah, it can return anything, and I think the key thing there is there's a way that you can. I think this would qualify as advanced usage. So I haven't even written about this, and I've gotten my own experiments to work. But you'd have to declare you'd have to know what that coroutine return is returning, and then you'd have to declare the multi-type for that, the multi-return type, and then you could proceed normally. It would just expand those. It would capture those variables, with that inside that multi-return type.
Just wondering if you'd like to interrupt with if you can't figure it out, just like array of giant or something.
Yeah. Oh yeah, I mean, like nothing's stopping you from packing the return and then iterating over it normally. I think that'd probably be the most sane way if you weren't absolutely certain what was coming out of that resume. So we're on thin ice there for me. I don't know all the use cases for that, and if there's some tricks or some things I could do, I'm all ears. So please.
I was curious what kind of implementation effort is required to build a new backend like this. So for example, do you compile from some Haxe intermediate representation or straight from the AST? And also, how many lines of code did you have to write to build this backend?
So those are all great questions, and I think, why don't we talk later? One of the things I pitched in the summer session was a lot of people were interested in, how do you write a Haxe target this way? And so when I started out, I actually in my mind, did a painstaking, almost journal of, my thought process on building this out, and it's all in the Git commit log for the Haxe compiler now, and I give you some commands you can run to filter it out. So I'll share that with you after the session.
Great, thanks.
One more question.
I'm very curious about the compatibility of basic data types, because you're targeting both 5.1 and 5.3. For example, what happens with the integers? Does Haxe have separate types for things with the 64-bit integer?
It does. So it has so if you look at it, has an in type, which is basically the platform dependent type. So you don't count on that being anything. But then it also has has an int32 type. When you use that, depending on what target you're using, it'll do one of two things. Either it will just declare that as the platform type, or it'll do bitwise operations to make sure that after every operation you pass to that type variable, it ends up being a 32-bit end. That might incur some overhead, but it gives you, you either get, type safety or you get speed, and then you work, as an extern author or someone that's working on a platform like that, you have to work out how to make the Haxe code work as fast as possible or as flexible as possible. You have that power, but it's also a responsibility.
Does it have 64?
Yes, and that's really tricky.
Or because it's
It's for Lua too. You can use it. You can do 64-bit integers on the single float type. And yeah, if you're once again, if you're curious, I can show you after the session. That was a nightmare to implement, but it's there.
Yeah, well, I mean, for what I want.
Yeah.
Ah,
Yeah, and then I haven't done anything, so Lua 5.3 is kind of the horizon for me. I think there's some new stuff there, and I'm trying to figure out how to take advantage of it. And yeah, good questions.